So, hello everyone. Today is research proposal assignment number 9. My name is Nolfin Ilya. I'm a computer science student in SD University. So, let's start. Firstly, we start with introduction. In the last decade, the rapid growth of online platforms has revolutionized the way users consume digital content. Among these platforms, YouTube stands out as the world's largest video sharing service, hosting millions of videos and attracting millions of daily users to provide personalized and engaging user experiences. YouTube relies heavily on artificial intelligence, particularly ML, algorithms that analyze user behavior and recommend videos aligned with their interests. So, an AI-powered recommendation system works by processing large-scale user data, such as watch history, likes, comments, and search patterns to predict collaborative filtering, deep neural networks, and reinforcement learning. YouTube continuously adapts recommendations in real time, aiming to maximize watch time and user satisfaction. These algorithms play a crucial role not only in improving user engagement but also in driving revenue through targeted advertising and content monetization. However, despite their success, AI recommendation system face significant challenges. One key concern is algorithmic bias, where certain content is unfairly promoted or suppressed, leading to echo chambers and reduced content diversity. Another challenge involves user privacy. Recommendation models rely on vast amounts of personal data that must be collected and processed responsibly. Moreover, maintaining transparency and explainability in such complex AI systems remains a major research issue as users, policymakers increasingly demand accountability from digital platforms. The aim of the research proposal to explore how AI and machine learning are used in YouTube's recommendation systems, focusing on their mechanism, advantages, and limitations. The study will analyze commonly adopted ML models, including matrix factorization, recurrent neural networks, and transformer-based architectures to understand their role in optimizing user engagement. Additionally, the research will discuss how ethical and privacy-related considerations influence the design and deployment of these systems. The significance of this research lies in its contribution to understanding how AI-driven personalization impacts digital media consumption. By examining the balance between algorithmic efficiency, fairness, and transparency, this study seeks to provide insight for building more ethical and effective recommendation systems ultimately. The project highlights how intelligent algorithms shape the future of online content discovery and user experience platforms like YouTube. So let's start with the methodology. This study adopts a qualitative, and analytical research approach to examine the use of artificial intelligence and ML techniques in YouTube recommendation system. The methodology consists of four main stages: literature review, model analysis, evaluation framework, and ethical assessment. Let's start with a literature review. Comprehensive review of academic articles, white papers, and technical reports related to a large-scale recommendation system will be conducted. Sources will include publications from Google Research and leading ML conferences and reputable journals. The focus will be on understanding the evolution of YouTube recommendation pipeline, core ML techniques applied, collaborative filtering, deep learning, reinforcement learning, the artificial shift of RNN based models to transformer-based models. Model analysis. This section will analyze the structure of YouTube recommendation system, typically composed of two major phases. First one, candidate generation produces a small subject potentially relevant videos from the full catalog using large-scale embedding, matrix factorization, and deep neural networks. Ranking stage applies advanced models such as recurrent or transformer architectures to determine the final ordering video recommendations based on predicted watch time and engagement. Pseudo-architectural diagrams and comparative tables will be used to illustrate model differences in terms of scalability, latency, and performance. Also, here is a evaluation framework. Here we have expected watch time, click rate, user engagement and retention, diversity and personal levels, and although direct experimentation, YouTube's priority data is not feasible. Experiments will be simulated on public datasets such as YouTube 8 million dataset or similar open source video recommendations dataset. Traditional evaluation metrics will be applied to assess model outputs. So here is the ethical privacy considerations. Here we have algorithmic bias and its causes, filter bubbles and echo chamber propagation, privacy and GDPR related compliance for data usage, and also transparency and explainability strategies. So let's move to the expected results. Here we have model performance insights, user engagement. Here we study anticipates that highly personalized model will increase watch time, user session duration, and the click rate. Algorithmic limitations. In this part we have difficulty in addressing long-term personalization, novelty, increased risk of bias reinforcement, and dependence on large-scale private user data. And in the end, we have ethical findings. It is expected that privacy-preserving strategies such as data anonymization and federated learning will emerge as promising solutions, yet balancing transparency with proprietary algorithm protection will remain an unresolved challenge. So here we have discussion session. The results suggest that while advanced ML architectures significantly improve recommendation quality, they introduce complex ethical and operational trade-offs. So firstly, impact on user behavior. technical trade-offs, ethical considerations, and the future directions. In future directions, we have here developing fairer recommendations algorithm, improving explainable AI approaches, enhancing content diversity without reducing engagement, exploring federated learning to protect user data, and overall, although YouTube's ML-driven recommendation system is highly effective, the balance between personalization, fairness, privacy, and transparency remains an open and evolving challenge. So here we have literature review. In the literature review section, we have overview of recommendation research, collaborative content, yeah, based filtering approaches, and the deep learning and the hybrid models. So also ethical and the social dimensions and summary. In summary, the literature highlights a rapid evolution from heuristic-based methods to deep learning-driven architectures that power modern video platforms, while significant progress has been achieved in accuracy and scalability. Challenges related to bias, transparency, and privacy remain active areas of research. This review establishes the theoretical foundation for the next chapter, which presents the proposed research methodology and analytical framework for evaluating AI-powered recommendation system on YouTube. So, that is all. Thank you for your attention, and see you. Goodbye.